Okay, for today, we're looking at functions and sequences. This is a mixture of 6 and 7 content. So it is very important, especially for when you take pre-algebra. So we're gonna look at, obviously, we're still doing the function tables. But the major difference is whether a sequence is geometric or arithmetic. We're also gonna be able to find the nth term in a sequence and then like writing the equation and whatnot. So for these examples, maybe, just kidding, just going back. For these examples here, again, remember a function is a relationship where there is basically exactly one output for every input value. So like there is one that matches the other for it to be a function. Now, in order for us to find a role, and again, these are two-step functions, so two-step equations to get these answers, because if you look straight across from here, we want to know the relationship between our input and our output, or our x and our y. Technically, this is y. This is our independent variable. This is your dependent variable if you want to go with science. I can't add 8 each time, so that's not going to work. I can't multiply by something, so that can't work. So how you find the rule is you look at the relationship going this way and this way. Okay, so from this to this, I add 3. From here, I'm adding 1. From here to here, I add 3. From here to here, I add 1. So the relationship is, therefore, you take the 3 and you divide it by 1. So you take your y difference and divide it by x. So really this is 3 over 1, which is 3. This is your coefficient. So it would be y equals 3x, because this is 3x. And then you figure out then if I multiply by 3 now, what do I have to do in order to get to 14? Okay, so if I have times 3, I get 18. So I have to subtract 4. So let's see if that works. 3 times 7 is 21. Subtract 4 is 17. 3 times 8 is 24, minus 4 is 20. So the answer is 3x minus 4. So where is this minus 4 coming from? This is when x goes all the way up to 0, okay? So wherever 0 is at the intersection here, okay? This is why this is not a proportional relationship, because this one will actually start down in -4. It would actually start down here, -4. That is right here. This is your, what we call in this, I'm telling you more than I should. This is your y-intercept. This is where your function, your linear equation, your linear function crosses the y-axis. This number in front of here, just letting you know, it's called slope. And that is something where it has to do rise over run. So basically, if I go back into here and I would go to 5 and 4 and 3 and 2 and 1, and I go, and then I subtract 3, subtract 3, subtract 3, subtract 3, subtract 3, subtract 3, until I get up to 0, I would get -4. So let me prove that to you. This would be 11. 4 less than that would be, or 3 less, sorry, 3 less than that would be, why can I not think? 8. 3 less would be 5. 3 less would be, that goes with this goes with this goes with this. 3 less than that would be 2, so that would be that. 3 less than that would be -1, and 3 less than that would be -4. So basically, your plus whatever, your minus whatever would be where x is 0. That's your y-intercept. Okay, so in this equation or this function here, basically you would have, it'd be a linear function, make a line. However, it is not proportional. And the reason why it's not proportional is because it does not go through the origin. Okay, so again, this would look something like this. Okay, obviously if I filled it all out. So how do you get the output? We multiply by 3 and then subtract 4. Okay, so let's look at some more examples. So what is the rule? How do I go from my x to my y? So I'm going to figure out how I go to my x to get to my y. Okay, so let's do the same thing I did before. What is the relationship going down here and here? This is still adding 1. This is adding 2. So y divided by x is 2 over 1, which is 2. So I'm going to multiply by 2. So right now I have y equals 2x. And basically wherever 0 would be at, or whatever it would be to get to 11, is my y-intercept. So let's see. If I take this and multiply it by 2, I get 10. So I have to add 1. So let's see if that's true. Times 2, add 1. Yep. Times 2, add 1. Yes. So in this case, your rule is to multiply by 2 and then add 1 to get your y. So 2x plus 1. So this right here is your y-intercept. That's where it would go through the y-axis. And this one here is slope. And basically your slope is your change in your y over your change in your x. Hence why I did y divided by x. Okay, again, telling you more than that. I'm not going to tell you specifically what that means, but generally that's how you do it. Okay, so there is your equation or your rule. Look at this one, same idea here. I'm going up by 1s here. I'm going up by 7s here. So I would do y divided by x, so that's 7 over 1, which is 7. So that means I take my x, I multiply it by 7, and I have to do something to get my y. So if I multiply by 7, I get 14, so I'd have to subtract 1. Make sure that works yet again. Times 7 minus 1 works. Times 7 minus 1 works. So it's 7x. So y equals 7x minus 1. That's the equation. Again, 7 is your slope, which they use m in algebra and they use b for -1. That's your y-intercept. So you'll see y equals mx plus b. That is the slope-intercept line. Hence the name slope-intercept. Again, just so you see that you'll be familiar with seeing, you'll see it again. It won't go away. Trust me. Okay. Same thing here. Add 1. Adding 3. So 3 divided by 1 is 3. So my slope is 3x. So times 3. So if I times by 3, I get 30. So then I have to add 5. And then if you check that, it should work for all of those. There you go. 3 is your slope, 5 is your y-intercept. That's where it would go through the line. None of the ones I just showed you are proportional. Why? Because they do not go through the origin. Okay? All right, so let's look at something different here. Now this example is slightly different because we have a little bit more going on here. This is going up by 2, right? And this is going up by 2. And then this is going up by 3. And then this is going up by 3. Regardless, if I take y over x, which is 2 over 2, which is 1, right? And then if I do here, y over x, I get 3 over 3, which is 1. So the answer is still y equals 1x, or y equals x. And this one actually is only a one-step equation because all I have to do is add 6. But again, you might have realized that initially. This one is not a two-step equation. It's not a two-step. It's only one. Well, technically two because you're multiplying by one and then adding 6. But again, this one is not proportional still. It will not go through the origin. Why? Because it goes through the origin at, or goes through the y-axis at 6. The slope is 1. Your coefficient is your slope. Again, those are words you're going to hear. I'm not going to test you on that part. But again, keep that in mind. Okay, so what a sequence is a list of numbers in a specific order. Okay, so when we're finding the next 3 terms in the sequence, you just figure out what the rule is. What rule do you see going on? Well, if I'm looking here, to here, to here, to here, to here, to here, to here, is it times 2 or is it add 8? Well, in this case, it's add 8, add 8, add 8. So the next term in the sequence would be 40. Add 8 would be 48. Add 8 would be 56. So again, in this situation, if you are adding the same number every single time, so if you're using addition to get the next term in your sequence, this is called an arithmetic sequence. Okay. All right. So therefore, if we looked at all these examples here, let's see, is this times 2? No. So it's plus 3, plus 3, plus 3. So since this is doing addition repetitively, this is an arithmetic sequence. Okay. So therefore, the next term would be 15, add 3, add 3. Okay? So again, that's an example of an arithmetic sequence. This one as well would be arithmetic. But then we get down to this. So what if it's not addition? What if it's multiplication or division? So this has a different name. So right here, this is not add 3 now. This is multiplying by 2, multiplying by 2, multiplying by 2. So this would be 48, 96, 96 plus 96 is 192. I think I did that right. Yeah, okay. So therefore, if you have repetitive addition to get your next, so you're multiplying to get your next term, technically adding or subtracting, multiplying or dividing. This is called a geometric sequence. Okay, so this one would be a geometric sequence. Okay, this one I am subtracting a half, so this would be arithmetic. This one I'm multiplying by 3, so this would be geometric. And then this one I'm also multiplying by 4, so this would be geometric. So again, the difference between if you're adding arithmetic, geometric would be the other ones. Okay, so that's how I remember adding arithmetic. Okay, so again, arithmetic sequence is each term is found by adding the same number to the previous term, whereas geometric is each term is found by multiplying by the previous term. Technically, if I was using subtraction, like if I am subtracting, it really means I'm adding a negative number. And if I am multiplying, that's the same as dividing by the reciprocal. So again, it does apply to the inverses of addition for that. But again, A for adding the same number, that'll help you. Okay, so if I would look at this sequence here, okay, sequence can all be also shown in a table, okay, as an algebraic expression. So again, this time I want to write an equation based on the relationship between its position, so the first term in the sequence, not going this way, but how am I going to figure out each term as I go? So again, If I want you to ask you to write an algebraic expression to figure out the relationship between n, its position, and the value of that answer, you have to look from your input, which is technically your x, and your output, which is your y. That's not like I showed you there. Sequences are lists. I'm not asking you to do this. Don't do that. I want to know the relationship. So you should see it very easily. How am I going from my n to get to my answer here? All you're doing is multiplying by 8, multiplying by 8, multiplying by 8. I'm not asking you to tell me it's a geometric sequence. Just because I'm multiplying by 8, that does not mean it's geometric. That means if I was multiplying the actual numbers. So in this case, the answer for this, what is the algebraic expression? It's an expression because there is no equal sign, because I'm not equaling it to anything, is whatever position I'm in, I have to multiply by 8. So if I ask you, what is the 5th term value? Okay, so if it was, that's done. What would be the 15th? So if n was in the 15th position, what would the answer be? All you would do is just do 8 times 15, and that would give me the value of that answer, or the value of that term. So if I'm in the 15th position, what is the value of that? You use the algebraic equation. So this would be a 0, carry the 4, 120. So literally, if I continued on this pattern, keep on going, keep on going, keep on going, I should get to 120. Okay? Same thing here. This right here, if I had, this is the first position, second position, third position, fourth position. Okay? If I wanted to figure out the nth position, going from here to here, here to here, here to here, here to here, okay? I would take n and I would be multiplying by 3 for this. So 3n is the algebraic expression. So again, if I wanted to know what is the value of the term in the 10th position, all you do, the 10th position, which is your n is 10, you would just do 3 times 10, which is 30. So if I continued this on, I would get 30 as my solution. This right here is not the same as this right here. This right here, I'm actually adding 3. This part shows me that this is arithmetic sequence. This part shows me what the algebraic expression is. I want to know the relationship between the two. So keep in mind that I don't want you to tell me that it's, because it's multiplication here, that it's geometric. It's not. The answers 3, 6, 9, 12 is adding 3, so that's why it's arithmetic. Okay, so same here. Do the same idea as well. From here to here, here to here, here to here, here to here. How do I go from my n to my position? So you have to look at it. Am I multiplying? Am I adding? What am I doing? Am I adding 3 each time? No, not adding 3. Am I adding 2 each time? I'm not, so I can't do that. So we have to go back to what we did previously. The change here is add 2, right? And this is add 1. This is add 2. This is add 1. So what is, this is technically my x and this is my y. I would do y divided by x. So 2 divided by 1 is 2. So therefore, I would take my 2, multiply it by n. But then if I multiply by 2, I then have to add 1. Does that work? Times 2, add 1. Yes. Times 2, add 1. Yes. So the algebraic expression is times 2, add 1. So 2n plus 1 is how I would find my terms. So again, if I ask you what the value of the 12th position, n is 12, you just do 2 times 12 plus 1. So that answer would be 24 plus 1, so it would be 25. All you're doing is just figuring out the rule using what we learned before. I'm noticing this is adding 2. I notice that the add is adding 1. 2 divided by 1 is 2. So therefore, I have a two-step equation here. By the way, this one is not proportional. However, the last one I did, that's proportional. And that one's proportional because they would go through 0, 0. Because if I plugged in 0 and multiplied by 8, I would get 0. Hence why it is proportional. Right here, if I plugged in 0, I would get 0 because I'm multiplying by 3, so therefore it is proportional. Whereas this, if I plug in 0 and I multiply by 2 but add 1, no, I'm going to be at the y-intercept at 0, -1. Or positive 1. That's why it says plus 1. That's my y-intercept. Okay. So then again, same idea here. This one is not a one-step equation. This is a two-step equation or rule. So how do I go from here to here? This is add 5, add 5, add 5, add 1, add 1, add 1. So y divided by x, because remember this is x and this is y. 5 over 1 is 5. So it's 5n. So I'm multiplying by 5. And then how do I get to 6? If I multiply by 5, how do I get to 11? Adding 1, adding 1, adding 1, adding 1, adding 1. So that is my algebraic expression. It's an expression because it does not have an equal sign. Okay? How did I know? I could also check it to see what it was if it was at 0. 0 should be at 1. Well, if I multiply by 5 and add 1, I get 1. Hence this value right here. So again, how do I find the 35th position? You plug in n into your expression. So 5 times 35 add 1, whatever that is, that would be your nth term or nth position value. Okay, so again, it might look like this. Which expression was used to create the table at the right? So again, if I'm asking you this, all I'm asking you to see is what is the relationship between your input and your output? What is the rule? So again, you could see, is it add 4? I don't know, let's check. Do I add 4 each time? No. Is it multiply by 5? No. Is it multiply by 3? No. It should be times 2, add 1, or add 3. Here's why. This is going up by 2, this is going up by 1, this is going up by 1, this is going up by 2. 2 divided by 1 is 2, so that's why it's times 2. Okay? And then in order for me to get to 5, I have to add 3. And again, that works every single time. So it's taking what I just showed you and then applying it to sequences or nth terms and whatnot. Okay, so then again, if you need more examples, there is some right here. However, there's one on here that I want you to pay attention to. Oh, it's these two. This is like more of like a challenge. So for this one, same process. Am I just multiplying by something? No. Am I just adding by something? No. So I'm going to look at the relationship here. This is plus 4. However, this is plus 28, right? And this is add 2, but this is add 14. So what am I really multiplying by? Don't tell me 28. Don't tell me 4. It's my y divided by my x. So 28 divided by 4 is 7. That better give me the same answer for the other one. If I take 14 divided by 2, right? 14 divided by 2, I still get 7. So far I need to multiply by 7 and then see if this works. Do you add 3 every time? You do. So your equation is y equals 7x plus 3. So if this is not a 1, you have to take these and divide it. So same thing here. This is add 4, and this is add 12. And if this is add 2, then this is add 6. Again, if I take 12 and divide it by 4, I get 3. So right now it's times 3. But if I also take 6 and divide it by 2 at the bottom here, I still get 3. So it should be times 3. 2 times 3 is 6, and then you have to add 7. 6 times 3 is, wait, what did I do wrong? No, that's right. 6 plus 7 is 13. 6 times 3 is 18, plus 7 is not 45. What the heck did I do? No, that's right. That doesn't give me the answer. Okay, 12 divided by 12. Yes. No, it's not 12. Oh my goodness. I'm an idiot. It's not times 3. This is not add 12. This is add a lot. Oh my goodness. Anyways, let me fix this. Erase it all. Because apparently I can't add today. This is add 4 and this is add 2. Okay, I got that perfect. This is not add 5. Or whatever, 6 or whatever I put. Oh my goodness. 45 minus 13 is, let me make sure I'm right. Oh, 32. Okay, and then 61 minus 45 is, that's a 6. 16. Okay, hold on. Let's see if I get it right now. Okay, 32 divided by 4 is 8. I better get 8 on the next one. Okay, yes, 16 divided by 2 is 8. Let's see how I knew I did something wrong. So times 8. Okay, I agree with that. That would be 16. And then if I subtract 3, I get 13. Okay, times 8 is 48. Yes, minus 3. There we go. Times 8 is 64, minus 3 is 64. Okay, got it right. So the equation here is, after I made a mistake, 8x minus 3. See, I made a mistake because apparently I don't know how to subtract, but I caught myself. So there you go. I said we're not perfect again. But again, it's okay. We all make mistakes. So that'll be the end of this for today. Okay, after I made beautiful errors. All right, so that is the end of the lesson. See you tomorrow. Hopefully I can, do this right live. Oh my goodness, I'm a hot mess.